I made a project a while back. It was an adapter to adapt these Black & Decker 20-volt max lithium batteries to a T12 soldering iron kit. And since I had already designed this bottom receptacle, I thought I would make another project that makes an adapter to adapt these Ryobi 18-volt power tools, plus one, I believe, or one plus power tools to the same battery, the 20-volt max Black & Decker. I was given several of these tools a few years ago, but I didn't really have a battery for them. All I really had was, this is the remnants of what it was. I believe they were nickel metal hydride batteries. So I had to design all this top section in Fusion 360, and the latching mechanisms. Also have this Sawzall type reciprocating saw. Also have a little flashlight, but it doesn't have a bulb in it, so I won't even show it. This is the adapter. It's made of a top, this receptacle, and there's also a little shell here. It's just a cosmetic thing to make it look prettier. These are the latching mechanisms. The top is made of two parts. This part and a little cap that captures the terminals. I'm going to disassemble it and show assembling it so people who want to build it will know how it goes together. It's designed to use just a few hardware pieces. Mostly the screws are all 3mm by 12mm. There's two springs in there, 8mm by 12mm, I believe, and some brass strip that I'll show when I show the assembly of it for making the contacts. That's the hardest part of making it. I'm going to disassemble this now and show how it all goes together. So here are the parts that make up the adapter. We have this I called the top. It comes in two pieces. This is the top cap. There's a screw going through it that fits down in here to capture the terminals. I'll show how those go in a minute. This I call the receptacle. It's the part that mates with the battery. It's derived from the project I did before in a T12 soldering iron. These are the latches, but this is what I actually designed the thing when I started with a little flashlight that I also got with it. And this latch is what holds the battery in. There's a little lip there that catches on a protrusion right here on each side. You can see it here real well. Okay, there's two of those. This is strictly a cosmetic piece that I designed as an afterthought because I wanted it to look a little better. You don't have to make this. It just makes it look a little nicer. It's about a 3-hour print. These other parts print in about 6 hours each. So it's 12 hours to print the basic and another 3 hours to print this cosmetic part. You'll need 2 screws or 2 springs. These are 18mm long by 7mm. They come in a spring kit I get from Harbor Freight. You just have to scrounge around and find something that works. The hardest part about making this is you have to make these pieces right here and these pieces. I made the larger pieces out of K&S brass I got from Hobby Lobby, 32 thousandths or 0.8 millimeter brass. I provide a little template for this, but you can just lay on there and mark out, and have to cut it out as best you can. I used snips to cut out to basic shape, and then I used an old Radio Shack nibbling tool to do the rest of it, which was quite handy. That's probably the hardest part about making it. These are actually, I bought this stuff from Hobby Lobby also. It's a 32 thousandths brass, same thickness as the other one, but it comes in 1/4 inch strips, which is just the perfect size to mate to these spade connectors, female connectors. They'll go right on there. Then you just have to cut this to length and build and bend it. Here's the part number 5078. Just made things a lot easier. Although if you want to, you can cut just 1/4 inch strips out of this. It's the same thickness, just a lot more trouble. These are just female connectors, 1/4 inch. I use the blue ones. These wires are 75 millimeters long. You can make this all up ahead of time. There's the springs with screws. All the screws in the final version will be 3 millimeter by 12 millimeter. I had to fix something in the CAD file right at the last, so I'm having to use these 16 millimeter long screws that go through and mount these. But in the final version that I'll post, these will all be 12 millimeters. I just didn't want to reprint this part again. So let's show how it goes together. Once you've made this up, I bend, here's how it goes. 10 millimeters on one side, 20 millimeters on the other side with a 3 millimeter or 1/8 inch. I bend it around an 1/8 inch drill to get that radius. The top of this is radiused. You just have to play with that until you get it right. These are made when this is a test print I made earlier of just the top part of it. When it's printed, this part will have a sacrificial bridge on it. So you'll have to go in and cut this out. You'll have to go in from the bottom and cut the sacrificial bridge out with an X-Acto knife. And I don't remember if you have to drill that out or not. The screw may not be long enough. But there will also be a sacrificial bridge right here. You'll have to cut it out first. So cut this out and then cut these square places out for the terminals to go. I just printed this as a test print. You can see how they fit together. Then a screw goes through to hold and capture the terminals. So let's try to put it together. First we need to know the orientation. Red one on the right. And you can run this down through there even after they're assembled. Black one on the left. And you put the cap on, it's all located. And screw it down with the 3 millimeter by 12 millimeter screw. Make sure you get your polarity right, or you'll be messed up. Now we have to put these in. These are definitely the hardest part of a project to make. The reason I have them angled in is because this is all a tight fit between here and here. So I've got them angled in just a little. They go with the this part toward the middle, the terminal connector part. I'm probably going to go in and fix a CAD file to add these to the markings straight to the print. I thought I had that done, but I didn't. And then the version you'll get, these will be 3mm by 12mm screws that go in from this side through that hole. The hole is an 1/8 inch or a little over 3mm. 3mm will probably work. That's what captures this terminal. Now we just have to hook our wires up. And then stuff it all down up through there. You probably ought to use flexible wire for this reason. If you don't, these could be definitely made shorter. You just have to play with it and see what you get. But if they're not this is a wire from an old RC car speed controller. It's pretty flexible. Made those wires too long. It made it hard on myself. And these line up in your 12mm, 3mm, or 3mm by 12mm screws. Now we have to put the latches in. Put the springs in first. There's a little tunnel there that they'll fit down through. They go with a barb facing out, and also the pusher facing out. There's a little post there to engage the spring. 3mm screw going through here. Spring, latch. Hopefully they don't launch us into the next room. Screw. You can see what I've actually been using this. I went out and cut up a bunch of stuff with a Sawzall this evening. It was the first time I'd ever been able to use these tools, even though I've had them for years. I'm glad I finally got around to doing this. Now it should be in a testable state. You can, whoops, smack my camera. At this point, probably be a good idea to get your meter out. And test it. 18 volts. These batteries are down a little from when I was using them. And then we can test it. And it works. You can also keep bumping my camera. You can I just made this as an afterthought. This little, I call this the shell. It's just a cosmetic piece. When you print, I'll show how to print this stuff in just a minute, but there's 3 screws to hold that on, just to make it look a little prettier. You don't have to print it if you just want the functionality. Just makes it look a little nicer. It does, you have to hold this down a little longer to get it to disengage from it because of this lip sticking out here, but it's no problem. Works good. Fortunately, I don't have a bulb for this light. To find one. It's pretty sturdy. Only time will tell. When you print this, I didn't get it right the first time, as you would imagine. This prints like this, no supports. Straight, just on the bed like that, no supports. This is an old version of a receptacle from, I think, when I was building my soldering iron. It'll print like this, but it does have supports, and this is a hard part to print because of all the slicing. You want the only place you're going to want supports is right in here. These are the ones I took out. They'll go right in there. Surprisingly, they come out very easy when I sliced them with cure. I thought it would be a bear, but you want supports there. But you have to put support blockers in so that none of these holes get filled up. And that's kind of a pain. It takes longer to slice it than you would think because of that. You have to put in support blockers for all these holes. What else? Oh, and on the final version, there's support blockers for in here too. Like I say, when you slice it and do the preview, the only place you want to see supports being added is right here. Or you'll never get the stuff out of these holes. These latches print like this. Reason for that is you don't want them printing like this where they lay flat against the bed. I don't have a spare one ready to show it to you. I think I got those right in a couple of tries. But you don't want to print them like this because the layer lines, this would just break right off probably. You want it printed with this right here on the bed. That way that there'll be some strength as far as holding it together when it's pulling against this nub. See what else. The cap on this prints with this face down against the bed. No supports. There's a sacrificial bridge in it too. You just have to drill out. That's no big deal at all. When you're making it, make sure these don't get too long and hold the cap up off of this. If this is too long, it'll keep this cap from being down all the way. It won't hurt if it's a little short. You can see I've been using it. Actually quite handy. Trying to think if there's anything else I should mention. There's a diagram of a 1/4-inch strip terminal. Wire 75 millimeters long. You could probably use shorter wires. Springs 18 by 7 millimeters unsprung. You could probably get by with a little shorter on that. You just have to figure out what you got. And 12 3mm by 12mm button head screws. actually pretty proud of this. It seems like it's going to be a very useful thing to have. It's meant to work on these Ryobi tools that had 18-volt Ryobi tools that had nickel metal hydride. I'm not sure what modern Ryobis use, or if the physical interface is different or anything. This is what I had, and this is what I've designed this for. Well, I'll post all the files on Printables and Thingiverse. I'll try to post with step files too, in case somebody wants to modify it. They're far easier to modify than STL files. Well, thanks for watching.